So good to welcome you to the set, and I'm so glad we're able to put this together, and the books are really, really good. And I'm looking forward to talking to you some about your writing and so forth. Last time we did a lot about the magic that you were able to do, but welcome very much to Conversation.
Thank you.
My great good pleasure. And welcome to you in the audience to the Conversations. The guest today is Dorion Sagan, and he is a writer, I would say, extraordinaire of science and other matters. He's written a book now that we're particularly wanting everyone to know about, if I could. I'm going to hold it up here. It's called Notes from the Holocene, A Brief History of the Future. We want one and all to know about this. I would want one and all to know. It's a marvelously written book that brings a great deal of understanding of crucial scientific understanding to the citizenry, as it were, in a very, very lively fashion. And there's another book I want to let people know, published by the same publisher. It's called Dazzle Gradually, a takeoff on the Emily Dickinson poem that was co-written by Dorion, our guest now, and Lynn Margulis, who is his mother, as it were. We're going to talk some about that. Very important writing, both of them, books you can hardly put down if you have an interest in the human condition and the evolution of technology and consciousness and so forth. And Dorion, welcome, really very, very much. It's so good to see you. Could you share a little bit of your own background, personal background, born and raised, educational? And we want to talk some about your scientific writing, and then we're also going to say at the end, like frosting on the cake, you are also a sleight of hand magician extraordinaire. But could you talk a little bit about your own personal background, and then we'll talk about some conditions of scientific understanding of this universe in which we dwell.
I was born in a blizzard in 1959.
Pocatello, Idaho?
In Madison, Wisconsin.
Okay.
Yeah. And lived in California when I was very young, and then we moved out to Boston. And my parents split up at an early age. I went to schools mostly in the Boston area. I'm a graduate of the non-Ivy League school, University of Massachusetts.
University of Massachusetts.
I went to Boston and Amherst. I spent a little time in the Museum School of Fine Arts, which is in Boston, in a non-degree program. I audited some courses at Harvard. I lived in Florida. I had a son who's now a white rapper. I think you heard some.
Great. I saw some of that work. He is great. What's that one piece he does? White is black, or what?
We'll be white, black.
Yeah, right.
We'll be white, black, and rappers are repetitive.
Yeah.
Tonio Sagan, yeah.
That's Tonio, yeah. It's an interesting name.
Yeah. I'm just a vector between the generations.
Yeah, okay.
Making a pit stop on your local access show.
Yeah, right. Okay, that's really good. And you're in the family setting. You had an interesting family setting, if I may say so, because you were in a very intellectually rich environment in terms of your parents and so forth. Maybe you could just share.
Yeah, my well, there's a funny little story about I hope I didn't say this in the last show. Not that anybody who watched that won't be watching this one.
I don't. You know,
it's one of those stories.
Yeah.
But after I was just almost out of college, a famous literary agent named John Brockman, who had really begun the science writing genre in the United States. He was the agent for Gregory Bateson, and he did some stuff with Andy Warhol. And so he's always on the lookout for possibly interesting scientists to generate popular books. And
he worked with both Warhol and Bateson?
Well,
that's a pretty wide.
Well, he didn't work. He hung out with Warhol, and then he became the agent for Bateson. But anyway,
Bateson's really serious.
Yeah. I like Bateson.
Yeah.
And he came to solicit a book from my mother when she was living on Commonwealth Avenue, and I was hanging around, and he said, yeah, I want you to, he came in with a big pimp hat, and he said, I want you to write a book on popular science. And she said, no, I can't do that. You should talk to my ex-husband. That's his forte.
Yeah.
So I started shooting my mouth off about the search for extraterrestrial intelligence being a replacement for religion in a secular age. And he goes,
well, how old are you then? Huh?
I was like 22 or something. Yeah.
Your prime. Yeah. Okay.
And he said, that's good. Why don't you write a book? You could write a book about growing up with your father. I said, okay, but I'd have to make it all up because they split up when I was 3. Actually, it was 5, but
Yeah.
for some reason I had 3.
Well, they're formative years.
Yeah, and
They're up to 5.
and he said, "That's fine as long as it's nonfiction." So that was the that was the beginning of my serendipitous literary career. But yeah.
Yeah, but your mother, you write with, is a noted biologist. She's won an award, I think, from President from President Clinton.
Well, yeah, she got
for
a
scientific writing.
Yeah, in 2000 she got a Science and Technology Award.
Good for her. She deserves it widely. Yeah, I mean, in great depth. She co-authored many of the articles in Dazzle gradually. And as I told you on the phone, told her I had a brief conversation. I could not put the book down. It's so well written.
It's down right
Well,
there.
it's down now, I know, but I couldn't put it down as I started reading. It's really, really good, a major contribution that you two collaborated on. And she's a noted biologist of the highest order, yeah.
Right.
So to be in that environment is important because it's intellectually stimulating, huh?
Yeah, but after she and my dad split up, she hooked up with a crystallographer, a chemist, and they got some pretty rarefied dinner table conversations. Not your usual fare. They're discussing like the crystalline structure of colchicine at the dinner table.
Yes.
So us kids had to, it was sometimes difficult to get a word in
That family
edgewise.
setting is really important, don't you think?
Oh, yeah.
Apart from, let's say, the formal schooling and that kind of stuff, the family setting and is really important, I think.
Yeah, I mean my scientific knowledge, insofar as I have any, is almost entirely osmotic. I mean, I got a C- in microbiology at the University of Massachusetts, and then I went on to like co-author several books on it. So.
Yeah. So go into the cool.
Well, that's not my. That's
thermodynamics.
Yeah.
Yeah. Right. Yeah. But that's still good and everything.
And that was with Eric Schneider.
Yes, we're going to talk. Well, I want to talk some about that because that's a major
yeah.
book, and you're also researching those, thermodynamics and the gradient and that sort of thing. But I mean, a couple of things there. Formative years, 0 to 5, are really informative years. That's time. Somebody said to me, it's all set. So some people see that it begins in the womb maybe, and then it does. But to have an interesting environment like that, was it? Let's just say psychologically, was it a permissive environment that you were in? Everybody that I know when my kids were coming up was reading Dr. Spock. And there was a permissiveness abroad in the air. Was it that sort of a thing, or was there heavy disciplinary lines laid down by these intellectual lights that were your parents?
As far as discipline, and my mom did read Dr. Spock.
We all did, I think, yeah.
Not to be confused with Mr. Spock.
Right.
My dad was a little bit more like Mr. Spock. And he wasn't, he was kind of that kind of 50s generation with the sort of distant paternal figure, more a father than a dad. Milan Kundera makes that distinction. I tried being a father, but I ended up being a dad.
That's an interesting distinction.
Yeah.
You have a great chapter about him in your book.
Yeah, I wrote
It's very beautifully written.
Thank you, yeah. I wrote a memoir.
And that, of course, was Carl Sagan, who was one of the most noted scientists in the history of mankind for his Cosmos series and so forth.
And may even be known in extraterrestrially due to the propagation of air waves at the
That's right.
speed of light into outer space. If they're looking for life,
I think
some
the
funny
first
cartoons
television
about that.
picture that went out into the universe, I think it was Howdy Doody. I'm not sure.
Well, that's probably what happened. They were probably looking for life in our part of the solar system, and then they saw Howdy Doody, and they just turned the channel off. It's like, come back in a million years and see if anything's happening.
But back to that that setting in the family around the dinner table. That's where a lot of interesting things goes on. And was it? I had mentioned to you I had a person I did some programming with who was the smartest person in the world, Marilyn Mock, Beau Savant.
Yeah.
She's smart. She has the highest IQ, whether you trust the idea of IQ, of any person in the history of humanity that was able to test it and so forth. And she said that and she could talk on anything really very knowledgeably and so forth. Has that article, a weekly article, a column in Parade magazine now. But she said in her environment when she was coming, it was totally permissive. She could just do whatever she wanted.
Interesting.
And they would say, "Why is the sky blue? Go look it up, dear." It was permissive, and that sort of thing in terms of encouraging people to investigate their own capabilities.
I definitely had intellectual stimulation. Emotionally, maybe not. It was maybe a little more stilted than would be ideal. I'm not saying I was kept in a drawer.
What would be ideal? What's
Well,
the ideal setting for the youth,
I
or
mean,
for the infant coming into the world? I mean, I wonder.
I wonder too. I mean, it's
like if you go to eat and they have these things where you have to take baths in the middle of the night and get cold and it's very hard, Spartan, that kind of stuff.
Yeah.
People think that all the way over to Carl Rogers, all the way over to you know, behavioralism in terms of psychology.
Yeah, well, Alice Miller wrote a bunch
Yeah.
of books on child rearing, and all the mass murderers were, you know, they were brought up under rigid environments, including, you know, walking around in hospitals with no, you know, they usually had no parents, no touch at an early age. And,
really? Yeah.
And,
yeah.
But the thing is, there's a dialectic there because,
Yeah.
you know, this Anglo-German sort of child rearing is pretty, you know, Spartan and
Yeah.
austere and severe, and it works insofar as the children who are brought up in that setting tend to be, all things considered, better warriors and more able to battle, but, you know, that comes at the cost of their own personal development. I mean, they have actual torture instruments that were considered part of normal German child rearing.
Right, then they really were tortured.
And look at my
and
mom.
they think they're going to teach toughness and
Well,
practicality
yeah, it
and
has a
these
religious
kind of
dimension.
things, you know.
Like even my mom, my mom was, like I said, like, as you asked, was a reader and devotee, as was almost everybody in that generation of Dr. Spock. But still, when I had my son, you know, she said, well, if the baby is clean and fed and he's crying in the room, then you just leave him there. Now that was still considered lenient, you know. That's still like within the realm of Mr. Spock. But if you think about it from this sort of Alice Miller perspective, there's a sort of hidden cruelty there in that, you know, a human needs to be held and touched.
Absolutely.
And they could be having some existential freak out looking at the, you know, stationary mobile.
Sure.
And maybe that, you know, they have, but, you know, I mean, where's the line? You don't want to necessarily, you know, sleep with your children in the bed. You know, you don't want to necessarily breastfeed them until they're 7 years old. You know, it's a gradient.
Yeah, it's a
of,
thing. Yeah, right.
Of the austere child rearing that leads to a certain kind of toughness that might have survival value versus a permissive environment.
A lot of the people from another generation, and times change and everything, that sort of thing and everything. And so the thing is, it's permissive, and it might go back to people's notions of something that we would call human nature. You've got a thing of writing in Dazzle about the nature of nature, or the the nature of nature,
Reflection
including
of the nature
human
of nature. Is the subtitle,
people have certain ideas about what human nature is. Some people say it's inherently within the evolutionary pattern, greedy and this kind of thing, and self, you know, that kind of thing. So those things vary. But raising kids, the children and the infants is really important, that context by which they come out, because they're coming out learning like crazy right at the very beginning, I understand. Just very quick learning going on and patterns being set and so forth. So you were in that pattern till you were about 5 or so.
Yeah, I used to, I got this line from one of Theodore Sturgeon's short stories, Symbiotic Abstraction. So I used to like joke at the dinner table about the hyperkinetic microtubulistic variations of the symbiotic abstractions. I was just trying to throw out the gobbledygook at the same rate.
That sounds like a haiku. Right, yeah.
At the same rate.
Symbiotic's an important word, don't you think? I think it is in terms of understanding evolution of consciousness and so forth. The thing is a symbiotic kind of thing. It seems to me your mother's used that.
Yeah, she does. I'm reading a book now by Michel Serres, the French philosopher. It's called Parasite. And Parasite is actually close in terms of ecology and evolution to symbiont.
Yeah.
But interestingly, in French, the word parasite means not only host and but guest and static. So it's an interesting word.
And static.
Yeah. But
yeah, there were parts in the book, in the notes, I think it was, there were parts in the book about the evolutionary process is symbiotic, and it was compared to another notion of the process of species emergence and so forth, that it's a symbiotic kind of combination rather than another notion of how species appear and so forth, which is part of the writing that you and your mother have made.
Yeah, well, that's one of her...
A big important issue on singularity of new species evolvement.
Oh, yeah, it's a huge part of her work that I've popularized over the years, and people still don't realize it. Symbiosis, they know about symbiosis, you know, fungi and algae make lichens, and there's relationships between various species where they mutually benefit. If they don't, it would be parasitism if one was just taking advantage of the other. But what they don't realize generally, even though it's in the textbooks now, is that symbiosis is absolutely crucial to the evolution of species.
Yes.
If you look through the history of time, you find that the first organisms on the planet were bacteria and archaea, and it was symbiosis between these very relatively simple sorts of cells that led to all of the more complex cells that had nuclei in them, and animals, of which of course we're a part, plants, fungi, and more complex microbes called protoctus or protists. They used to be called protozoans, but that suggests that they're just pre-animals, but they're actually pre-plants, pre-fungi, and other organisms. All come from a merger, and the merger of the bacteria was it was kind of like sex in that they came together, but unlike sex, they came together permanently, and they, depending on the individuals and the lineages that got together, they derived different benefits. But our bodies, every animal cell in our body, if you look at it genetically, you can trace the genetic fingerprint back to respiring bacteria that were around several billion years ago on the planet, and this plant has got the plastids or the chloroplasts.
It's plastic.
Well,
so it goes back to the fossil fuels.
Okay. If this were a real plant, the green parts of the plant cells would have come from cyanobacteria, which is actual photosynthetic bacteria that were multicellular. Did a lot of stuff happened before there were any animals or plants, and paved the way for it. And a lot of it was symbiogenetics. So even famous evolutionists like
Gould,
Stephen Jay Gould,
Eddington, or
no, Stephen Jay Gould.
Yeah, but he worked with another fellow, Eldridge.
Yeah, Niles Eldridge. Yeah, he wrote the introduction to one of our books.
Yeah, and they've got a notion of punctuated equilibrium.
Yeah, but that's what now. But what I'm
relevant or not?
Not to what I'm saying. But
right. Okay.
But basically, it could be in that the biggest jumps in evolution tend to be through mergers of very unlike beings that come together in permanent ways. And we also wrote another book. It's not in this Chelsea Green series. So we have an imprint now with Chelsea Green. Does
good.
the Both these books are part of the Chelsea Green Science Writers Books series.
Right.
And we have some other books like Animate Earth by Stefan Harding, and we have Eduardo Poncet, who's kind of like you. He's sort of a Spanish talk show host who specializes in science, and he wrote a bestseller in Spain called The Happiness Trip. That's also part of this lineage. But one book before these books that we've done with Chelsea Green that I co-wrote with my evolutionary biologist, symbiosis expert mother, was called Acquiring Genomes, and that showed that when you look at the actual evidence for the evolution of species, although it's usually taught that gradual mutations lead to new species, and that may well be the case over very long times, but in fact, when you look at the actual examples, examples are from organisms coming together over relatively short periods of time and forming totally new beings. So when you look at the actual evolution of species, a lot of it is through symbiosis. And somebody like Stephen Jay Gould, who's basically a zoologist, who specializes in more recent animal evolution, went so far as to say that life is all about diverging species. But what happens in these cases is that different species, different types of organisms come together and make a new species. So the bush of the tree of life does not just branch out; it also anastomoses. The branches also come together, and you can see stuff like that happening even in the technological realm. Although technology isn't a biological species per
No.
se, but you see this process of
Yeah.
things coming together, of genes. I mean, bacteria don't have the same sort of sexuality that we do.
Right.
They can trade genes from one to almost all their genes.
Yeah,
And
it didn't necessarily, evolution didn't have to go along a sexual line. It could have gone in other ways, perhaps, and everything. But I wonder, maybe we could back up. Why don't we go? We've got a term that's thrown around. We've got a lot of people talking popular, like, say, a term like singularity or something like that. If we go back and we got the special theory of relativity, we have more understanding. We have an understanding of the process of which we're a part. We know that we're all walking in a sea of bacteria and that it's an interrelated system that we are a part of. And the Vedics have been telling us that it's a seamless web. And so we tend to break everything down into hierarchies and so forth. But where can we begin with that? We've got this idea, let's say maybe quickly, we don't have to go into detail, the notion of the Big Bang. Taking apart, let's say, away from, let's say, string theory that's being developed in physics now. The Big Bang, 13.7 billion years ago, there was an event in this part of existence, the Big Bang, that began this universe as best we can understand it. Does that make sense? They got telescopes and take a picture of the shock wave only 200,000 years after that.
the microwave background
But that would
radiation.
be, in a certain sense, for us, a singularity, a sort of beginning point in terms of the fact that all of this exists, including the universe and all of the things within it. But is that a beginning point for our understanding of things and a singularity of a certain sort?
Well, that's pretty much the accepted astrophysical scientific canon that everything began. I guess it's 13.7 billion years and now, give or take.
Give or take a day or two, maybe next
In
Tuesday.
an infinitely dense
No,
point,
but
but
it's
I
amazing,
talked to
Dorian, it's amazing to me. They got this telescope, Wham or something, no, Wilkinson, and they take a shock wave for 200,000 years only after Big Bang, and they got a solar array now. The financing's all in place, I think, with CERN, and they're going to take a picture of the shock wave 13.7 billion years ago, I think by 2011, and they're going to be able to take a picture of that within 1 second of the beginning.
Yeah,
of
it's interesting.
That's a pretty amazing capability to take the measure of things from this.
It's
little
interesting.
dot
Don't
in
you think it's
the
interesting
universe.
that as we move forward in technological time, that our ability to image the past becomes ever more acute. So if you extrapolate theoretically, at some point in the future, we may have almost perfect knowledge of the past. So that seems unlikely, but it does seem that we're asymptotically heading in that direction.
But it's an amazing capability to take the measure of things by this consciousness that has emerged out of that. So then if we go and we talk, so let's just come forward at a certain
On the other hand,
yes.
if I can just interject
By all
about
means.
you asked me about the Big Bang. I did talk to Philip Morrison, who died recently. He was a physicist. He was one of the people who armed the bomb in the atom bomb that landed on Hiroshima. But he had polio as a kid. But I remember talking to him one time, and he said, well, you know, that's a pretty huge assumption. You look at what's going on now astrophysically with the stars more or less all heading away from each other. As my dad once said, as if somebody had committed a cosmic faux pas. But you assume that by doing a retrodiction that they existed in one single, infinitely dense point.
Compact in there.
Yeah, there's a pretty big assumption when you try to find, you go 2 blocks on MapQuest and you realize that the map is, as Gregory Bateson liked to quote, the map is not the territory. Even the territory may not be the territory.
Right.
So, I mean, that's the bigger you're dealing with, the more chances that things can go wrong. Now, I look at things, and when I wrote this book, Notes from the Holocene, I used not only science, but I used science fiction, for example, Philip K. Dick, and A.E. Van Vogt, and Theodore Sturgeon, and Isaac Asimov, and other people. And I also use philosophy, because sort of the edge of science, in a way, is philosophy. What are the assumptions of science? And I like to not necessarily just, spout whatever authorities. I like to think things through for myself and recommend that. And also, finally, part of the methodology of my investigation of these really big questions, like why are we here?
Right. That's a
why do we drink water?
Yeah.
You know, how can anything exist in the first place?
Whatever happens to the lost sock?
Where do socks go when they die?
Where do socks go in the
That was
dryer?
a bonus question.
Yeah, that was great. That was the end. Yeah.
But I used the psychology of magic, the psychology of perception and deception embedded in the practice of sleight of hand magic to approach some of these questions. And one thing that you realize in magic and the performance of it, which is basically an anti-intellectual field, you know, it's like glitzy girls and pianos and stage magic and stuff like that. But what conjuring has in it a lot of implicit in it is a lot of understanding of how people come to conclusions and how they can be fooled, and how all perception has a component of deception because you're never seeing the whole thing. You know, you got the backstage and the front stage, and we don't. And science, this applies to science too. And as far as the Big Bang and everything starting in this one point goes, one thing that we realize,
this universe.
One thing we realize from magic that gives cause for thought is that nothing ever appears, at least in sleight of hand magic. So we want to say the whole universe came from an infinite. What happens is that you have a secret cover. Like in what they used to call the black arts, I could have a stage that was all black, and then behind a black on black partition there might be a girl dressed like a rabbit or something, and then you could pull apart the secret cover, and then she would appear. But she didn't appear. She appears to appear. She was already always there.
So this applies to our physics.
So this suggests that everything didn't necessarily appear at one point in time. And I mean, this isn't. This might sound, this is just my crazy little sleight of hand, over the top, speculation. But actually, Stephen Hawking said himself that asking what happened before the Big Bang is like asking what's 4 miles north of the North Pole. It's not like these different disciplines, science fiction, theory of magic, and philosophy don't come together. And I find that one of the interesting things, really the one thing that I found that, and there may be other things, but the one thing that jumped out at me, a point of convergence between science, philosophy, and religion, of all things that you might think are diametrically opposed, although there's three of them.
There's a lot of people think that way.
Is that they all put a great value on humility. You know, you have Socrates and the oracle at Mount Parnassus and of Apollo saying, you know that you don't know in philosophy. You know, the one thing you know is that you don't know. In
a priori mystery, in a sense that even if we understand more, there will be other realms.
In science,
because the more we know, we get to pattern recognizing, we get to a point, and that'll introduce you to think, but there's still this advancing synergistic resonating mystery that is part of the thing that it might be wise to accept,
but my point
fundamentalist
is science works by checking their preconceptions against evidence and verifying. So that's an implicit humility in the face of reality. You can't just speculate wildly. Philosophy, you know that you don't know, and then in religion, the mother of all sins is pride, which is also, humility is a virtue. So I like to use that, and so I'm always, it's one of Charles Darwin's contemporaries, the great writer. He was also a painter, and he also wrote several books at his own expense on evolution. Samuel Butler said that scientists are the priests of the modern age, and they must be watched very, very closely.
Sacerdotes, you got to be careful with them. But apropos of all that, if I may, we were talking about the Big Bang and so on. You got this thing now. I just finished for a little while. This thing with the string theory coming, and it's Brian Greene, and I think Kaku's involved in that, and so on. And they come up with mathematics that postulates parallel universes. Now, and that there's nothing in universe but a resonancy between systems, inter-accommodating systems. It's all, and then they postulate that the wormhole is a connect, like bubbles, like you get ivory soap and you put bubbles, and this universe could be connected a wormhole to other universes, parallel universes. What do you make of all the string theory and the things that come out of string theory?
Well, maybe
it's not fair.
I don't have a
But that would be a thing before the Big Bang universe notion of this universe that we are.
Well, with regard to string theory,
yeah.
I am not you know, an astrophysicist or a
No,
mathematical
but,
adept. But my gut instinct is that there's something wrong. And somebody wrote a book recently called "Not Even Wrong," and it's become
not even wrong.
Not even wrong because the stuff is not necessarily testable. It's more and more arcane and complex mathematics to make sense of it, and there's not any necessary real world cognate. So I'm skeptical. You know, they went from what, 21 dimensions to 10 dimensions.
I think it's 12. I thought.
Yeah, I mean, I mean, there's a lot of ways to make sense of something, but.
But Mr. Einstein never did come up with a unified field theory.
Yeah,
quantum mechanics goes so far.
Yeah, I like what Steven Weinberg said, that a scientific principle is simple and impersonal, and I don't think that I don't think the string theory is simple. I'm not saying that the universe is simple, but but I mean, once you start postulating other universes that you can't observe, you're in the realm of metaphysics and philosophy, which doesn't mean that it's invalid, but it's not necessarily science.
We don't have meta-science. There's no meta-science because that's a contradiction in terms. But there are
I actually wrote an article for Skeptical Inquirer that had meta-science in the title.
Did it really?
Yeah.
How do scientists convert to the idea of meta-science? That's sort of like an altered ontology at the level of capability.
Well, philosophy in a way is
a lot of modeling is based
philosophy in a way is meta-science. For example, look at going back to that magic thing that I was talking about, how nothing in sleight of hand ever appears. It only appears to appear by the removal of a secret cover, and how that applies to thinking about these big questions that are on the edges of science. Well, it not only applies to the idea that maybe you don't get existence appearing ex nihilo from nothing, but it also theoretically applies to consciousness. I mean, in MIT, in these labs, they're trying to put things together in a certain arrangement so that somehow consciousness will arrive. There's kind of an assumption.
Like the media lab, the IA, AI stuff.
Yeah, there's an assumption that if you get a sufficiently complex computer developed parallel processing, that you will eventually get consciousness from the inside. But it's possible in Whiteheadian philosophy and in other certain styles of thought that consciousness and matter are two different things, and it's not clear that consciousness can come from any bit of wrangling about with the bits of matter, and that to me is another example of how it's kind of very simple ideas of you don't get something for nothing applies also to science, because to me it makes more sense that consciousness in some form always existed and doesn't necessarily appear. It didn't necessarily appear through some conjunction of matter.
That's something that's synergistic.
That's meta-science. That's meta-scientific. It's metaphysics, but it's not necessarily irrational.
It's like synergy behavior systems unpredicted by the sum of the parts. There's something resonating more than the sum, and so those are patterns that if you're in the womb and you're going to leave the womb, you can't know what it's like outside the womb, and you come into a new relationship to things. Apropos of which, I wonder if we come forward a little bit in time through the Big Bang, from the Big Bang, and we got the Earth,
the only direction
and
we
this,
go.
and this universe and this solar system and so forth, and the beginning of the Earth as a unique entity that we are the citizens of and so forth is what, about 4 billion years that the Earth formed?
About 4.6.
4.6 and so forth, and then that. Bring us through that. That's a singularity of a sort. And then bring us through what is it that created the idea, the life, things that had life and things that began to move out of a chemical stage and this sort of thing. And how did that process begin? The origins of life in the early forms that took, and how do we account for that? Just a few simple questions we want answers to.
Yeah, well, I don't know. I mean, it's possible life was, sent by aliens with a whimsical sense of troublemaking from some distant galaxy and some, advanced
Is there-
biochemistry kit and it landed on Earth.
Yeah, but is there an explanation for it out of the stuff of the stars, as it were, for there to be a movement from chemical elements that had no animation or life or anything to form in a unique way?
Well, this
so
is
that
part of
early life, virus, that sort of thing could emerge, and how do we account for it happening here? And it seems to me, I wake up every day and I'm amazed that anything exists.
Right.
How the hell anything
How
can
did anything exist
where
in the
everything had
first
to be in
place?
such a, it was just a very careful measuring of things where the Kelvin temperatures of the gradients of the things that it would emerge. But how do we account for the fact that on this planet, and your father worked so much on SETI and so forth, trying to find contact with life and so forth. We haven't yet, as far as I know, outside of people who have ideas about it. But that's a big question. And how did it happen? How long did it take? I saw a film on television.
Around a bit.
Yeah, I'm sorry. I saw a thing on television where 600 million years ago, I don't know if it's Cretaceous or anything, that all fauna was contained in unicellular.
That's
No,
Cretaceous.
not 65. No,
well, that's
no,
Cretaceous.
No. Back 650 million. That all fauna was contained in unicellular spongiform. Very simple unicellular spongiform, and all fauna was during. And we have the reptilian core as part of our consciousness. It's an enfolding. But when did the formation of life at the earliest stages happen, and how do we explain it? You do deal with the evolution, because that continues along a line of consciousness that we could maybe investigate a little later in the program.
Well, if my brain doesn't explove from trying to parallelly process
you're writing about
all those questions, I know, but you asked about 15,000 questions.
And you've got to do it in haiku. So you've got to get 30-second sound bites, because you're living in the modern
Well, to me,
era.
one of the most interesting things about the origins of life in terms of looking at it from the present is that our bodies are chemically very similar to the early solar system, to the solar system when it arose, to the inner solar system. When the sun ignited nuclearly, hydrogen was very rich in the early solar system, but since hydrogen is the lightest element, it tended to escape into outer space. So right now, when you look at the solar system, you find that the hydrogen is in the sun, of course. The stars are mostly hydrogen. And then it's around the big planets, including the moons of the planets such as Jupiter and Saturn that my father used to study, that may have contributed to his death through these organic compounds that he called tholins. So it's sort of a brown gook that they find similar colors and chemical evidence of on the surface of
Europa?
Europa, Titan, some of the big moons of the outer planets. But so what happened? What looks like happened. But the other place where there's a lot of hydrogen, it's not on Mars, it's not on Venus, it's not on Mercury, it's on Earth, and it's mostly in the form of water. And it's also in life. We are hydrogen-carbon compounds. Life consists of hydrogen, carbon, sulfur, phosphorus, nitrogen, and I'm forgetting one of the chemical elements, phosphorus. Did I mention that? And but the hydrogen carbon core of life seems to be related to the fact that life arose in an environment where hydrogen was more prevalent. But through the cyclical process of metabolism, of keeping itself going, sometimes called autopoiesis, making oneself, we find that the whole surface of the planet Earth is hydrogen rich in a way that you do not see in this part of the solar system. So it looks like the very process of life has maintained it. What Eric Jantsch, who wrote an astrophysicist, who wrote an interesting book called The Self-Organizing Universe, called Time Binding. The actual space-time conditions of life's origins are maintained to this very day in this studio through this process of life. So in a way,
it's a miracle.
Yeah, that I
find
amazing.
Miracle,
And life's origins, there's a lot of different people working on it. It looks one of the more popular recent lines of work, and Friedman Dyson wrote about this in a book called Origins of Life, is that life may have evolved in settings similar to these hydrogen sulfide vents that were on the early Earth more closer to the surface, because you find some of the chemical reactions.
Vents in the ocean?
Vents in the ocean.
Yeah, the ocean deeps.
Yeah, there's a redox gradient between hydrogen and oxygen, and some of the chemical reactions that happen in a completely non-living manner seem to be similar to the chemical reactions that we find in life, and that combined with the sulfur metabolism of some of the putatively earliest archaean bacterial-like or bacterial forms of life, as well as other evidence such as the fact that some of these kinds of putatively early organisms were very are in the class of what they call extremophiles. They're very resistant to extreme temperatures and pressures, which seems to be the source of conditions that prevailed in the early solar system. So that's one of the avenues that people are looking at right now. Could life have arisen in sort of this
in the ocean
very high, high pressure, high sulfur rich.
Sulfur rich is the ocean
and on a gradient,
smokers,
because
smokers
that's in those kinds of places,
and there are life forms
which were just
there
found in the 70s.
There are life forms there that are not even photosynthesis related.
Right,
at all.
and they don't necessarily need light.
There may be
and these systems before life, but leading to life,
before life leading to life.
Before
That's an interesting singularity notion.
Yeah.
And what do we have? If we think bacteria and then the viruses, and viruses are in a certain sense intermediary between bacteria and chemical or something.
Well, it would see if you draw like a
crossover thing.
Yeah, well, it may be more likely that viruses, rather than being on the way to bacteria, are little pieces of bacteria that got sort of chopped off, maybe irradiated, and then had their own thing, rather than being truly alive. Because a virus does not reproduce on its own. It needs the metabolism, the working energy flow and metabolism of a living cell. A virus by itself can't do anything. But it's like a tractor. A tractor by itself can't do anything, but you put it on a farm and it can accelerate a lot of things. And, that's
a metaphor for technology in a sense.
Yeah, it's kind of that's the way I
So once the thing got started, okay, we've taken care of the Big Bang, and we've taken care of string theory, and we've taken care of multiple universes and so forth, and the physics of all that, and now we've got life. So now we come to where we can understand the evolutionary process by which all of this Gaia-related, interrelated world has emerged and so forth. That's something you've taken a great deal interest in. Thermodynamics, you've written a book with Mr. Schneider on thermodynamics. Maybe you could talk some about the evolutionary process itself by which we arrive at this studio talking to one another.
Another little question.
Species, evolution, you were talking some about that. Evolution of species, variations.
Well, you asked me about this thermodynamic stuff, and I could segue from
this. Yeah, you might spell thermodynamics, second law, that kind of thing. It's a very important concept. It might be worth just mentioning that.
Yeah.
You put a lot of attention on that. And you're working on that now, I think.
Well, I will be working some more on that, because down the line I have under contract to write a book with the
with Ms. Schneider
with the humble title, Purpose of Life, which would be
well, there you go. You're the man we can put the question to, right?
Which would be a popularization of some of the ideas, especially the last chapter on teleology and Into the Cool, which is published with the University of Chicago Press.
Let you know about that. That's another one we didn't have the book. Into the Cool is a really serious book. I've read good large parts of it, and I congratulate you, Mr. Schneider, on that also. But
it's a little dense, but we'd like to do a more popular version of it. But the point about
we've got about 15 minutes left in this program.
Right.
So we want to get this in, and then we want to show a couple magic tricks.
Okay.
Conjuring.
Okay. The point about these early living systems that were not alive but were theoretically on the way to life in these possibly sulfur-rich environments that were pressurized and
arcane,
hot, in the Archean environments, is that they theoretically belong to a class of complex systems. When you look in the real world, the complex systems that you see are not generated by laptop computer programs. They're not They're not two-dimensional. They don't have programmers. What they are is natural designs that have a form and a function, which is the same thing, which is a thermodynamic function, which is to reduce gradients, to spread energy, because although people get confused about the second law and say it has something to do directly with the promotion of disorder
or chaos.
In fact, the basic idea of the second law is very simple, and that is that energy spreads.
Maybe we should bring it up to date a little bit. The second law.
And
first law is no conservation of energy. The second law is closed systems. Is that correct?
Well, it started in isolated systems, but I was trying to, within the 15-minute time span that
we have to
to
get
say
the haiku.
something that appears, is something that applies both to isolated systems, which means thermally sealed systems, closed systems, which is open to energy but not to matter, but also to open systems. All of the systems that are complex, that appear naturally and spontaneously in the universe that we know about, are open energy flow thermodynamic systems. Thermodynamics just means heat flow. So these systems include naturally cycling, systems where cycle matters in regions of energy flow, and life itself may be another one of these systems. Now, life is able to reproduce itself, but you find things like Taylor vortices, Baynard cells, even very simple systems like the swirling whirlpool at the bottom of your bathtub, or tornadoes. These are organized in regions of energy flows. What they do is they break down energy gradients. A gradient is just a difference across a difference that's measurable. So you got appearing in the atmosphere between a high and a low pressure mass, a very complex system that if you were like, if you were theological and you were on the lookout for evidence of a deity, you would say, how the hell did you get this spinning system that with all these molecules,
like a machine to me,
meticulously organized? Well, here the form is the function, because the form is this tornado. The function is to reduce this pre-existing difference. And this is perfectly in accord with the second law's mandate to produce entropy, to spread energy, and to reduce gradients. However, in so doing, it forms a complex system. The complex system is better able to get rid of the pre-existing differences than just any kind of random system. So
and that might be indication.
So life itself may be doing the same exact thing, except the gradient it's reducing is between the very hot sun and cold space. It also is spreading energy.
Degrees to 2,000.
You don't have life that does. You can't have life in a box. Life is an open system. Life is taking in matter, and it's producing waste, and it's also producing entropy as heat. So what this suggests, to go back to the metabolic systems that might have been involved in the origin of life, these systems are naturally complex systems on the way to life that are maintaining their complexity in a primitive fashion, but possibly on the way to life in the same way that tornadoes grow and are complex in the regions of, that's a pressure gradient, but this would be more of an electromagnetic gradient. You can have temperature gradients, and you can have chemical concentration gradients. You have these Belousov-Zabotinsky reactions, which are very complicated, psychedelic chemical reactions. They're not alive, but
they're not fractal stuff.
Well, they do. Fractals is part of this, but the point is that the real complex systems are not the models on the computers. The models on the computers are like the real systems are in three dimensions.
Yeah, we can learn from real systems.
It's like
it's like carbon-60's coming. That's the thing that exists in the real.
Well,
it's like the basis of all cybernetics.
It's like Edmund Husserl said, back to the things themselves, the things themselves, rather than not models. Look at the things themselves. What are the real complex systems that appear? Not the stuff that people
we
make.
Can model.
Right. Yeah.
Now you come. Okay, that's good. You did have a thing in one of the things I read where you said the sun had a certain temperature and space had a certain temperature, measured Kelvin or something.
Right.
And the fact that these things are somehow dealt with in this, and that it makes for an argument, because you, like James Lovelock and the idea of Gaia and the idea that there's an organic nature to the existence of this planet or something like that. Maybe it's worth trying to get some of that in here now if you can. And this gradient between the heat of the sun and the outer space.
Yeah. Well, the
sun's 5,700 or something, or
I think. Can
Temperature.
Something like that, Kelvin,
And then you had a thing for outer space,
2.77, yeah, Kelvin.
I didn't know that. Yeah, okay, and that's, okay.
Well,
And there's a basis in there for there to understand the organic nature of the Gaia premise that is looked at as
that the Earth has a physiology, that the Earth system as a whole looks like a living being. If you look at
organism.
If you look at, well, not necessarily an organism, maybe a superorganism, but anyway, a sort of gestalt entity that has a physiology. Because if you look at the chemical nature of the atmosphere, there's no way that it should be that you should have hydrogen-rich compounds in combination with oxygen-rich oxygen that you do on a continuous scale for millions of years.
Millions and billions.
And also, if you look at the evidence in the fossil record for life, it suggests, because life only does not exist between except between freezing and boiling, that the surface of the temperature of the Earth, the mean temperature of the Earth, has persisted within a very narrow range, despite the fact that in the evolution of stars, there's an increase in luminosity. So how did the Earth maintain its temperature?
Yeah.
How did it maintain its atmosphere? How did the alkalinity and the acidity of the environment become maintained? Not
that could
absolutely.
Be evidence of organic. That could be evidence of.
Well, that's evidence
that
the surface of the Earth is like a body.
Right.
Okay, and Lovelock was hired to by NASA to look for evidence of life on Mars, and he realized
you didn't even have
that you didn't have to go there. And because you could look at the atmosphere and see that the atmosphere is in chemical equilibrium. It's almost it's over 90% carbon dioxide on Mars. It's over 90% carbon dioxide on Venus. But Earth's atmosphere is not in that exhausted state. The carbon dioxide-rich atmospheres are moving in the direction of what human technology is doing with the greenhouse effect by putting so much CO2, which is a waste gas. So the genesis of Gaian idea of the Earth being truly physiology on the surface is thermodynamic. So this idea of these complex systems that occur naturally and that cycle matter in regions of energy flow is perfectly in keeping with Jim Lovelock's oeuvre.
And do you think the idea of Gaia, or the idea of an organism and like that, is gaining credence among scientists, or is it still thought of as something that is beyond the pale of what could be accepted in terms of a scientific process and scientific method by a lot of scientists that do not want to ascribe to the idea of this organic function?
Well, I think it's
because that gets to philosophy and things, and it also gets down to human purpose. It also gets down to technology as extended consciousness, and a lot of other questions that are kind of interesting, particularly if you get down to things like political economy and so forth.
Well, from a practical standpoint,
because it is all one system, Dorion.
Right.
Yeah. Okay.
Yeah, he talks about academic apartheid. I mean, philosophically, it's been repressed because in the geology and biology departments, there's a veneer of deism that clings to the notion of Gaia, which is named after a goddess. Not only is it theological, but it's also feminine. Yeah, it's feminine. So science spent a long time trying to divorce itself from any vestiges of
deism,
of theology, and so that's not. It was good for it to get accepted in the popular space, but it creates sort of a knee-jerk reaction. On the other hand, the research programs in these biology and geology programs often are very deeply influenced, even if they don't necessarily know it, by this attention to the biological component of geological processes. As Alan Watts liked to quote, life is no more, Earth is no more a rock with some life on it than you are a skeleton infested with cells. So the division between the geology and biology, life and the Earth, is an academic division. It's classic hair splitting on a cosmic scale.
Well, it goes on academically all over the place. Now, one last little thing. I want to get a word in for somebody I like. Bucky Fuller used to look about. He used to say he would look at all the things going on, thermodynamics and everything. He would cast, as he put it, I would cast about for a function. Is there a function, or a purpose? Let's just use a word. It's a loaded word. A purpose to the biological process. And he indicated the whole biological evolutionary process of which we are a part and so forth, taking the measure of the universe 13.7 billion years ago and so forth, is an anti-entropic function in the universe itself. And that he came to call it syntropy, a synergetic anti-entropic function, and that we'll get to a point where we'll have a singularity where there will be another level of understanding of the a priori mysterious design of universe. That was that's Teilhard de Chardin. You talk about the omega point, convergence, and all of that, which would have been led up to, if we'd had the time, by the technological extensions of consciousness, the cyber developments, and the geopolitical reality that we now have a system with weapon systems that can destroy the whole species, or perhaps create a new condition out of the evolutionary pattern that is qualitatively liberating of the whole of the human society and the biological system in a new resonating kind of relationship in universe. But are you optimistic for the human prospect?
Hallelujah. No, yeah. I felt like saying, like,
oh, I'm sorry.
After your
no, that was just, that's the way.
Am I optimistic about?
Yeah, are you? Because we have weapons now, apparently. Mr. Kaku and others will tell us that we have these weapon systems that we use with great regularity throughout history, and that if they're unleashed in a spasm of hatred, as we've been doing with great regularity to one another, it would apparently mean the end of this hominoid line.
I mean, if you look at the evolutionary history, there's been several mass extinctions.
65 million?
And
five, I think, 5 mass extinctions.
Yeah, they sometimes consider the human begotten one to be the 6th. But in many cases, the combined, the TNT equivalent of putative meteoritic impacts were far greater than the massed nuclear weaponry explosions of the superpowers at their height. So if you look at the graph of it, the number of species and taxa increases. There's a blip. It's kind of like the stock market after a crash. It recovers and goes on. And that's what you see in the history of life. Now, human beings we're a vertebrate species. Most vertebrate species only last a few million years in the fossil record. We could, as Terence McKenna said, become hallucinogenic, symbiotic angels and be one of the few exceptions in the fossil record that somehow symbiotically merges with the rest of life and gets to the stars, or we could be another species that doesn't make it, which most of them don't. I mean, if we either go extinct really, or we're going to split off into new forms. That's what happens.
We've come to the end of time. I'm sorry. We've come to the end of time, the very end of time. Dorian,
I knew this would happen. Okay.
Hope we got it in, and it's for your pleasure. We haven't been able to. We didn't get to show the magic tricks.
We'll read the book.
Read the book. It's magic.
It's described in there.
Conjuring hands. So it's your pleasure.
To a heart.
Dorian Sagan. End of that program. Welcome to the holiday season, and thanks a lot for coming.
Thanks
We're
so
going to
much.
do more of this, right?
Okay,
and
great.
Congratulations to you and your mother both on magnificent writing that one and all should be aware of and cotton on to, as they say. Thank you for viewing. We'll be coming back again, tomorrow. That's it for now. Happy holidays to one and all, and thanks again, Dorian. We're going to keep in touch.
Thanks much.
Coming back tomorrow. So, we just needed a yes or no answer if you're optimistic on the prospect. And you have to fill it out with all these,
I think that's a pot caught on the kettle black.
Yeah, right. Anyway, the book, I'm not kidding. I spoke to your mother briefly, and I could